Now, in the last lesson, we looked at the chocolate flavor of functions, which are functions that are able to take an input and use that input inside the function to do some calculation or to use it as a part of the code. Now, in this lesson, I want to show you an even more complex and also more useful type of function, which are functions that are able to give an output. So for example, taking the previous example where we're able to take money as an input to the function and use it to calculate the number of bottles of milk that we can buy, at the end of the code, we can use the keyword return to specify that this function, in addition to be able to take inputs, it can also give an output. And in our case, we're giving the output of money modulo 1.5. So remember that 1.5 is the cost of a bottle of milk. So money modulo 5 means that we're getting the remainder of how much we've spent to buy the milk. So if you remember, the modulo works like this. Whereas 9 divided by 6, 6 only goes into 9 once. So we get a remainder of 3. So in this case, the variable e is equal to 3 because the modulo gives you the remainder of the division. So in this function, if we gave an input of $4 and each bottle of milk costs $1.5, then the robot will buy 2 bottles of milk, which will cost $3, and it'll give us $1 change. And that $1 of change is the output from this function, which we can bind to a variable called change. So for example, we can say variable change is equal to the outcome of the function getMilk with an input of 4. And change will equal 1. Because remember, each bottle of milk costs 1.5, so $4 only gets you 2 bottles of milk, which costs $3, and that gives you a remainder of 1. So now the output of this entire function is equal to 1, and that gets assigned as the value to the variable change. That might take a little bit to sit in, but let's just review creating the function in this third type of functions. So the important things are we have the function keyword that specifies we're creating a new function. We have to give the function a name straight afterwards. And then inside the curly braces, we specify whether or not if we have an input that this function is going to use. And in order to get an output out of the function, we have to use that keyword return. And whatever gets returned in the function becomes the right-hand side of this function call. So when we call a function that has an output, we can use the output and we can assign it to a variable. For example, this case, the variable change. So if we didn't have this line where we have a return statement or specify that our function has an output, then calling getMilk only executes the function without getting an output back. So this is the most complex of all 3 functions. And this is the last flavor that we're looking at, which is the strawberry flavor, which incidentally is also the flavor that I never touched because it tastes awful. But our third function doesn't have to be awful, as long as we understand how the return works. So let's take a look at this in practice. So currently, we've got our function that takes an input called money, and it uses that input to calculate how many bottles of milk we're able to buy using that money. But at the end of the function, just before we hit the closing brace, we can add a return keyword and specify that we want this function to output a number. And the number is going to be money modulo 1.5, which is the cost of a bottle of milk. So this will give us the remainder of this division. So that means that if we give, say, an input of 3 divided by 1.5 has a remainder of 0, so we'll end up returning 0. But if we gave it a value of 4, then we will have a remainder of 1. And that number 1 becomes the output of this function call. So we can capture it and save it inside a variable called change, for example. And I can log the value of change by writing console log brackets change. So now if I hit run, you can see that all of those lines of code get executed and it shows me that I'm buying 2 bottles of milk, but it also shows me that I'm getting a change of 1. And that comes from this return statement. So this is quite useful because it allows us to use a number of functions inside other functions. So for example, if instead of messing up my bunch of instructions, I took this part where I calculate the number of bottles of milk I get based on money into its own function. So for example, let's create a function called calc bottles, and it takes an input in the form of starting money and also cost per bottle. So we can now say that the number of bottles is equal to this input called starting money divided by the cost per bottle, right? This is always going to be the same calculation that you need to perform, no matter which scenario. So you could have a starting money amount of $5, $10, $20, doesn't matter. And if you divide that by the cost per bottle of milk, then you will end up with the number of bottles. So now, how can we use this function inside here? Well, if we give this function a return statement, and we say that the output of this function is the number of bottles, then up here we can write console.log by plus calculate bottles using the amount of money we got as an input over here as the first parameter, which is starting money, and the second input, 1.5, as the second parameter, which is the cost per bottle. And now, once our code gets to this line, which is line number 12, then it'll go and find where this function was created, calculate bottles, which is down here, of course. It will place the value of money into starting money, 1.5 into cost per bottle, and it will calculate the number of bottles. And once it gets to this return statement, that value in number of bottles will replace this part of the code, because it is the output of the function. So now, if I call my first function getMilk and I specify an input of say $5, then that $5 is going to go into this parameter called money, and then it's going to move over here in order to use it to calculate the number of bottles we'll get back. So if I hit run, you'll see that all of the instructions are executed, and it also tells me that I'm able to buy 3 bottles of milk and have 0.5 as the change. Now, what if we did the same thing down here? What if instead of doing the calculation in here, we created another function and we called this function calc change? And the inputs that it's going to take is starting amount and also the cost per bottle. And inside this function, I'm going to calculate change, which is going to be equal to starting amount modulo cost per bottle. And that is what I'm going to return as the output of this function. So now, instead of returning this calculation, I can simply return calc change, and the first input is going to be money, and the second input, cost per bottle, is going to be 1.5. And that becomes the output of this function, which is getMilk. So instead of just calling getMilk here, I can also say console.log, call this function getMilk, and we're going to add it to a string. So we're going to say, hello master, here is your whichever amount that you get plus change. So now if I run the code, you can see that it goes through all of the commands, buys 3 bottles of milk, and finally we get, hello master, here is your $0.5 of change. So as you can see, what we're doing here is we're using the outputs of functions in order to use it inside other lines of code. So now, say if the cost per bottle of milk changed, right? Say it now costs, I don't know, $2.5 instead of 1.5. Then we don't actually have to change the calculation. And in fact, we can make this even more dry by reducing the repetition inside the function. So as an input, we can say getMilk, the amount of money as an input and also the cost per bottle as an input. And we can replace that here. So now when we call get milk, we have to say the amount of money we got given is 5 and the cost per bottle is, say, 1.5. So this will give us 3 bottles of milk and 0.5 change. But say tomorrow the master gives us $10 to buy milk and the cost of milk has gone up to $3. And now we're able to only buy 3 bottles of milk, but we get $1 change. You will find yourself using all 3 types of functions in a variety of scenarios, depending on what it is that you're trying to do. There's a lot of new information that you've learned, so it's really, really crucial that you try to understand this information by completing some exercises and trying to write the code yourself. So in the next lesson, I have an interactive challenge for you where I want you to write some code and we will use some software on our side to test your code and see if you got it right. So for all of that and more exciting stuff, I'll see you on the next lesson.